question 8, we already know that the Poisson process have the following form: Pnt1 T2 equals K equals to e to the power of minus lambda t times lambda t to the power of k divided by k factor. The first question is we have to find the expectation of xt. And the second one, we should find the RT1, T2. Since the Poisson process have the property of sum to 1, we can easily know that the sum from 0 to infinity e to the power of minus t lambda t to the power of k divided by k factor should be 1. And that is k from 0 to infinity, the sum lambda t to the power of k divided by k factor equals to e to the power of lambda t. Then we can do the derivative with respect to lambda to each part. That should be d by d lambda, the sum k from 0 to infinity lambda t to the power of k factor equals to d by d lambda e lambda t. And that should be the sum from 0 to infinity k times lambda t to the power of k minus 1. And that should be k times lambda to the power of k minus 1 t to the power of k factor equals to t times e to the power of lambda t. Then we can times 1 lambda to each side, and that became k from the 0 to infinity sum lambda k times t to the power of k factor equals to t lambda e to the power of lambda t. And now we can simply know that the expectation of xt actually equals to the sum from 0 to infinity k times e to the power of minus lambda t to the power of k factor. Then we can easily derive it from here, and that should be t lambda times e to the power of lambda t times e to the minus of lambda t, and that should be lambda t. And in order to find the second question, RT1, T2, we have to do the following derivative again. And that is, since we have k from 0 to infinity, the sum lambda t to the power of k to the power of k factor equals t times lambda times e to the power of lambda t. We have to do the derivative again, and that should become the sum from k from 0 to infinity, the sum of k squared lambda to the power of k minus 1 t to the power of k divided by k factor equals to t times e to the lambda t times 1 plus lambda t. And in this case, we just times lambda to each side, and the following becomes k from 0 to infinity, the sum k squared lambda t to the power of k divided by k factor equals to 1 plus lambda t times lambda t e to the power of lambda t. And now we know that the expectation of x squared t actually equals to the sum from 0 to infinity k squared e to the power of minus lambda t to the power of k divided by k factorial. And now we just derive this formula from that equation, and the answer should be 1 plus lambda t times lambda t. Now we know both the expectation of xt and the expectation of x squared t. And now we have to figure out RT1, T2. RT1, T2 by definition should be the expectation of x T1 times x T2. In this case, we have to do a simple trick, and the trick is the formula should be the expectation of xt1 times xt2 minus xt1 plus xt1. Since we minus first and plus secondly, the answer should be the same. And now we just take we just have to expand this formula, and the answer should be the expectation of xt1 times the expectation of xt2 minus xt1 plus the expectation of xt1 squared. And since we both know the expectation of xt1, since we know the expectation of xt and x squared, the answer should be easily, there should be lambda t1 times lambda t2 minus lambda t1 plus 1 plus lambda t1 lambda t1. And the answer should be lambda times t1 plus lambda squared t1 t2. And in this case, since we use the xt2 minus xt1, we should have a boundary that is t2 should be larger than t1. And in the second condition, when t1 is larger than t2, this part should become xt1 minus xt2. And the answer should be RT1 T2 equals to lambda T2 plus lambda squared T1 T2. And in summary, we have to take a conclusion, and that is RT1 T2 equals to the minimum of lambda T1 lambda T2 plus lambda squared T1 T2. And that's the answer of the question 8. Thank you.